Hey everybody, Trey here. Welcome back to another video. Back with another forecast discussion today as we have an enhanced risk, level 3 out of 5, from eastern Colorado into western and southwest Kansas and far northwest Oklahoma. Pretty interesting severe weather event on tap for today, although there are some caveats, and so I thought this would be an interesting setup to go over with a forecast discussion video. There is an all hazards threat on the table for today. We do have a 10% tornado risk area, so the tornado threat is somewhat elevated today across southeast Colorado, especially surrounded by a large 5% that goes up to the Denver Metro I-70 corridor down to the south, with a large 2% area extending all the way up into southeast Montana, into the Texas Panhandle as well. Damaging winds, a threat as well in that enhanced risk area, as well as large hail all the way up the corridor from southeast Montana down through Wyoming, eastern Colorado, especially in that 30% hatched area, and then down into northeast New Mexico and the western panhandles there. Again, I do see some caveats for today's event, so I thought this would be a really interesting event to dive into and take a look at why I'm not sure that the tornado threat especially will materialize, and I'll talk about that here in a second. Let's start off, as we usually do, with our water vapor satellite imagery. And you can see not a whole lot going on right now. You see a little bit of troughing here up into the Great Lakes region, northern plains, with pretty much zonal flow out here across the midsection of the country. We do see a couple of different complexes of storms ongoing here. One across Oklahoma, just had some rain outside here in Norman. One here from the Oklahoma Panhandle into southwest Kansas, and then one up here into northeast Colorado. So for our actual severe threat in Colorado today, which we're going to focus on in this video, of course, these are not going to be too much of an issue. We should see some recovery behind this complex. The actual storms themselves will not create any negative impacts on the environment here across Colorado. But that's not the only thing that we're looking at today. Wanted to show the satellite imagery. We'll probably come back to this in a little bit. But you'll notice here we have quite a widespread swath of low stratus, very thick stratus that is in place here, especially across eastern Colorado. We see a lot of this dense low cloud cover here out across Colorado. Here's your thunderstorm ongoing across northeast Colorado, complex there, weakening as it moves to the southeast across the Oklahoma Panhandle into southwest Kansas. But we do see a lot of stratus here out across this region. That is going to be the key for today as far as destabilization goes. A lot of models are showing that this may be stubborn to erode. It will erode eventually, but it may be some time before this starts to erode. What's the result of that? Well, that's going to keep surface temperatures a little bit on the lower side, and that may allow some inhibition, some convective inhibition or capping, to stay in place throughout the afternoon into the early evening when storms are expected to fire. So that is going to be the critical portion for today. We'll take a look at some model data and some forecast soundings as well to see how the different models handle the erosion of this low stratus, but it does appear to be pretty stubborn at this point, and that may create some temperance of the overall tornado risk, especially as storms may fire, encounter quite a bit of capping left over from the lack of full destabilization across this area, and storms may remain elevated. But that is going to, only time will tell as far as that goes. So we'll probably come back to that again in just a little bit. Let's take a look at some upper air data here right now, and you can see what we were talking about on our water vapor satellite imagery. Trough here across the northern plains into the Great Lakes region, extending up into Canada, and mostly zonal flow here across the midsection of the country. A little bit of a belt of enhanced flow here, extending from the west coast all the way inland into the central plains, 30 to 35 knots or so of flow, maybe even 40 knots here, up into Nebraska, South Dakota, into Iowa there around the base of this large long wave trough. But here across Colorado, mostly zonal flow, and that's expected to stay put throughout much of the day. We're not going to see an intrusion of any significant upper level waves here, shortwave troughs, etc., to impinge into the region. We will see just this stronger flow aloft, maybe some slight kinks in the flow. We'll take a look at some model data here in a second, but maybe some slight kinks in the flow, but mostly it's just this stronger flow aloft that will help initiate storms here, along with the higher terrain, of course, across Colorado into Wyoming, etc. And we don't need that strong defluence aloft like we talk about always, that spreading apart of those wind vectors with height. We don't need that always to initiate rising motion. We can have stronger flow aloft that does the exact same thing. If you can imagine, you have a region of air and you have this just strong flow aloft pushing that air away from a given region. Well, if we have that also creates that void that is left when you have strong defluence aloft. So the atmosphere likes to fill that void by bringing air upward from below, and you still can get some rising motion in this kind of environment where you don't have a very well-defined shortwave, but you still have some stronger flow aloft. So that is going to be the at least large-scale mechanism for storm formation here today across this region. Let's take a look down below. We would not expect to see significant low-level cyclogenesis because we don't have that strong, deep-digging trough here out across the west, traversing the Rockies. We just have this modest flow aloft, and so we should not see a significant response in the low levels. We actually have a surface high-pressure ridge centered across kind of northeast Nebraska into southeast to South Dakota, big high-pressure ridge there. We could see some semblance of surface flow development out in here near the Rockies today, which may help slightly back the flow here across this region, already starting to back in somewhat of what we call an upslope regime. Let me take you to our surface data right now. So you'll see that these winds right now are out of the east or southeast right now across the region. We, of course, have the Rocky Mountains in here, and so this is called upslope flow. You have winds that are going up that higher terrain, and that upslope flow can help initiate storms as air that goes toward a higher terrain feature, well, it can't go through that higher terrain feature. It has to go somewhere, so it goes upward. So that air is forced upward on the higher terrain, and so we should see storm formation here in this upslope flow regime as these winds kind of continue to back throughout the day, and that upslope regime is maintained. We should see at least some semblance of development here across the higher terrain west of I-25 in the Denver area near the DCVZ. You do see the DCVZ, or Denver Convergence Vorticity Zone, is somewhat in play today. You see that kind of counterclockwise curvature there out across this region, the Denver cyclone, if you will, definitely in play. A little bit of a convergence boundary there setting up near Denver as winds. So this is how the DCVZ works, the Denver Convergence Vorticity Zone. So you have what's called the Palmer Divide out in here in this region. Right in here, near Lyman, areas to the west. It's a slightly higher terrain feature. So you have the Palmer Divide, and winds out of the southeast or east go up over the Palmer Divide, and they meet the winds that are coming down, those downsloping winds coming off the foothills of the Rocky Mountains. That convergence is created there near the Denver metro area, and you can see that is a favored location for storm initiation because of that enhanced convergence there. That's why Denver is such a high frequency of landspout tornadoes. The Denver metro area and areas surrounding is because of that DCVZ and Denver cyclone in play. You do see that Denver cyclone looks to be in play today, that slight counterclockwise curvature there in the surface wind, so there does appear to be a little bit of that surface spin available for us to use out across this region. That storms could tap into that, but again, surface temperatures are only in the low 60s right now across this region. When those start to warm up is in question. When that low stratus starts to break off is when we're going to start to see more full destabilization. If those stratus can break away earlier, then we could see a little bit more warmth than what models are predicting. We could see a little bit less convective inhibition at the surface, and that could mean more surface-based supercells. But if we have those stratus stick around, we're not going to see temperatures warm all that much across this region. Therefore, any storms that do fire up here near the Denver area and work their way southeastward will have a tough time becoming surface-based because the temperatures will remain cool out here, and we could have some very strong convective inhibition to deal with. That may mean storms stay elevated for the duration of their travels down here into southeast Colorado. We do have nice low-level moisture here out across the region. We have upper 50s dew points here out near the Denver metro area, 60s dew points down here in southeast Colorado. Anytime you see 60s dew points work their way into Colorado, that is an eyebrow raiser. As we've talked about before, air at higher elevations does not hold as much moisture. So a dew point of 61 here in the higher terrain of southeast Colorado is like a 70-degree dew point in the lower plains, say in Kansas or Oklahoma or something like that. So that is very, very ample moisture making its way into Colorado. Probably could see some additional moistening here at the surface as we have winds out of the southeast. They will continue to back and strengthen throughout the day. So we could get these 63s, the 62, 63 dew points to work their way up into southeast Colorado for the storms to work off of. But again, it all hinges on the destabilization out across eastern Colorado with that stratus lingering throughout much of the day. We'll go back real quick and show you the situation here at 850 millibars. Not much to speak of as well. Again, we would not expect to see a significant low-level response with this just enhanced flow aloft. We're not seeing that strong deep digging trough aloft that would help to initiate cyclogenesis here in the low levels. So not much of a low-level jet to speak of. That's not a typical, not a typical sort of ingredient you see in Colorado tornado events a lot, is that low-level jet. Unlike areas on the plains where you would see a stronger low-level jet, not much here to speak of, although we may see somewhat of a slight diurnal or nocturnal increase in the low-level jet here, especially across far southeast Colorado and southwest Kansas into the Oklahoma and Texas panhandles. All right, let's look at some sounding data. Unfortunately, we do not have a Denver sounding from 12Z, 6 a.m. Mountain Time. We do have a Dodge City sounding, which is where the stronger surface moisture is located. So we can take a look at that and see the air mass that is feeding up into southeast Colorado here. So you can see already not much destabilization yet. Mixed layer CAPE at 0. We don't have a very deep moist layer, 64 over 61 at the surface, but you can see that red profile and the green profile do not stay very close to each other for a significant duration as you go up in the atmosphere. So not a deep moist layer. Shouldn't be too much of an issue. Would expect some moistening, especially as those low levels continue to moisten on that southeasterly low level flow. So I'm not too worried about that. But we do have quite a bit of capping to deal with, and that is going to be something that is going to be a little bit tough to erode today, I think, as that stratus stays around. So notice our convective temperature here is 89 degrees Fahrenheit. Our convective temperature is simply the temperature at the surface that needs to be reached in order for parcels to be able to rise freely into the atmosphere. So you see we're at 64 here at the surface. With all that stratus, 89 I think is going to be unattainable today. Now, convective temperature is solely based on, for example, surface heating. All you need to reach that convective temperature is surface heating. It doesn't take into account any troughs moving in, any upper level, large-scale support mechanisms, frontal zones, etc. So 89 degrees, that is quite high. I do not think we will breach that across eastern Colorado. Even in areas that do see full sunshine, I don't think we're going to get to 89 degrees. And we do not have, that strong trough aloft that would help to cool the atmosphere, lift that capping inversion, cool that atmosphere, as we would see ahead of a very strong trough. So I am a bit skeptical that we will reach that we will breach the convective temperatures today and fully destabilize. Again, it depends all on the amount of clearing that occurs across eastern Colorado. You can see we don't see that clearing ongoing yet at all across this region. Those stratus are here to stay, at least for the time being. So we're going to have to monitor that. That's why I am skeptical that storms will be able to become surface-based as they move southeast into eastern and southeast Colorado, especially if those stratus stick around longer. So just something to note there. Photographs, so you can see deep layer shear, 0 to 6 kilometer shear at 47 knots. So already a deep layer shear that is situation that is favorable for supercells. Not a great looking photograph, kind of an S-shaped photograph there, a U-shaped photograph. Significant backing in the mid to upper levels there. That should work itself out as we may see some increase in mid-level winds throughout the day, but low-level shear should begin to increase going into the evening, maybe a slight nocturnal increase in that low-level jet. Continued backing of the wind and strengthening of the surface winds could allow for some increase in low-level shear for any surface-based storms to take advantage of as they move into southeast Colorado. Keyword there being surface-based. Again, that's why we're skeptical of today's threat, especially for tornadoes, because storms may struggle to become surface-based as that convective inhibition struggles to erode fully. Let's look at some model data here. This is the 12Z NAM run, and we're going to take a look at a couple different models when we do some forecast soundings just to see how that capping erodes. So we'll start here in the upper levels, 500 millibars. You see that mostly zonal flow across the region, 30, 40, 45 knots here across the region. Some slight strengthening of that flow going into early evening, perhaps some. This could be convectively enhanced up there, but we still maintain about 35 to 40 knots or so out across this region. And that's all you really need out across Colorado. Colorado doesn't seem to work with these big, deep digging troughs all that often. It's these more subtle forcing regimes with just subtle 40 knots of flow aloft that do the best as far as tornado events go in Colorado. So Again, we have at least some modest large-scale forcing for ascent, fairly subtle, especially going into the evening hours. Let's go down to the surface. Let's go down to 850 millibars. Do we see a slight increase nocturnally in the low-level jet? We do see some 20, 25 knots out here, out across especially southeast Colorado, southwest Kansas, into the Texas-Oklahoma panhandles. Some slight increase as storms make their way overnight into this region. That could allow storms, after they've congealed into a complex, to maintain themselves for quite a while as they move southeast. That strengthening low-level jet, 40 plus knots of flow there, 850 millibars, could be enough to sustain storms there out across this region, sustain a strong MCS moving into northwest Oklahoma eventually, going into tomorrow morning. Let's look down at the surface. So let's take a look at our surface map here. So you see that strong surface high pressure ridge there across northeast Nebraska, initialized well. That's going to push off a little bit to the east as we get maybe some semblance of surface low development here, especially across southeast Colorado. The NAM does not have quite as strong of a surface low as some of the other models here. We look at the WRAP model. This is at 0Z, so 6 p.m. Mountain Time. You see a little bit stronger, a little bit better, more of a semblance of a surface low development there in southern to southeast Colorado. So the stronger the surface low, the more the winds in the low levels are going to be back, the more the winds will strengthen in the low levels. That would mean stronger low-level shear. And now let's take a look at some moisture here. So here's our moisture. You see early on dew points in the low 60s there, a little bit of a plume there in southeast Colorado. They try to make their way into Colorado quite a bit. Strong, tight dry line there, it looks like, in far southern Colorado. But again, our storm's going to fire on this low. Surface temperatures on the NAM, let's take a look here throughout the day. So we've got temperatures in the 60s right now. And you see they don't really get up that high at all. Temperatures remain in the low to mid 70s out across this region. And if you recall, our convective temperature was 89 degrees Fahrenheit on our Dodge City 12Z sounding. So again, I think that is going to be problematic for getting storms to become surface-based. And this just to show you that it's not a NAM thing per se, as we've talked about before. The NAM has a cool bias at the surface. Let's take a look at the WRAP model. 0Z temperatures much of the same, 72, 76 out in here, out across eastern to southeast Colorado. So I think it's going to be very tough to get surface-based storms here. I do think storms will eventually fire on the higher terrain near Denver and along that Denver cyclone area and move southeast. But again, as they move southeast, it's going to be tough to get them to become surface-based because of those low temperatures there out across that region. Of course, temperatures drop as you go into the overnight hours. So it's not just a NAM model thing that is showing this. Let's even take a look at the HRRR here. So this is the 12Z HRRR. We'll take a look at the convective allowing models here in a second. But you'll notice here the HRRR tries to get a little bit warmer, tries to approach that 89-degree temperature there, especially across the higher terrain out just west of I-25 there in southern Colorado. But again, out in this region, mid to even upper 70s, still well short of our 89-degree convective temperature there. So again, very skeptical. All the models are showing a little bit cooler temperatures out there across eastern and southeast Colorado. That should allow some capping to remain across this region. So even though moisture looks very good for a Colorado type event, dew points in the low 60s, more than adequate moisture here for a Colorado event. Let's take a look at some of the forecast soundings here. So we'll take one at 0Z, 6 p.m. Mountain Time. We'll take one here in just eastern Colorado. Then we'll also take one here in southeast Colorado ahead of these storms. So here is eastern Colorado at 0Z. So 72 over 60. Even if that is a little bit on the cool side, we still have quite a bit of convective inhibition to overcome. Now, mixed layer convective inhibition, only about minus 65. That is breakable. But it is going to be a nuisance, I think, that may inhibit storm robustness and surface-basedness, if you will, going into the evening. So some capping to deal with. 72 over 60, very good temperature dew point spreads there at the surface, almost 2,000 joules per kilogram of mixed layer CAPE. So plenty of instability. Just not sure about this capping inversion, if it's going to be a nuisance or not. Photographs a little bit on the wonky side. I think in southeast Colorado we should see a little bit better photographs. A little bit more capping though, as you see on the NAM forecast sounding here. Lots more capping to deal with in southeast Colorado. Let's take a look at some WRAP soundings from 0Z as well. See, a similar look to the moisture there. So we'll take one just south of I-70, and we'll take one in southeast Colorado as well into the better moisture. So let's take a look here. The WRAP again, the wrap is also showing quite a bit of convective inhibition to deal with. Long photographs, so deep layer shear is favorable for supercells. Low level shear, not all that strong. We do see a little bit of veering in the low levels with height. I do expect that might increase as we go toward 3Z here. We'll take a look at that in a second. Southeast Colorado especially, a little bit stronger low level shear to speak of, as the wrap, as we mentioned, had a stronger surface low down there in southeast Colorado. As you see there, a little bit stronger surface low than what the name was showing, so a little bit stronger low level shear out across southeast Colorado as well. But you do see, even though temperatures are a little bit warmer there in southeast Colorado, quite a bit of convective inhibition to deal with, about 161, minus 161 mixed layer SIN to deal with. So that is going to be problematic. That's a little too high to really attain surface-based storms. But nonetheless, moisture pretty good for the region. Wrap tends to undermix, whereas the NAM, as the models like the HER tend to overmix. The wrap tends to undermix a little bit, so I think 66 is going to be a little bit too high of a dew point. We probably will see something in the low 60s, but nonetheless, lots of capping to deal with. I think that's going to be the bugaboo in today's setup, despite a very nice looking photograph, especially for Colorado standards. Strong deep layer shear, 60 knots of effective bulk shear, over 200 meters squared per second squared of effective storm relative helicity. That's not going to matter. If the storms cannot tap into this low-level storm relative helicity due to this capping, then that is not going to matter. You'll see mostly a large hail threat and eventually a damaging wind threat as storms congeal into a line later this evening. So let's go forward to the next run, 3Z. We'll go to 3Z here on the wrap first. So we'll take a sounding here, eastern Colorado once again, and one down here in southeast Colorado for good measure. So you'll see here that photographs do look much better by this time, but still, as surface temperatures cool, I mean, wow, look at that. Very strong low-level shear in place out across southeast Colorado, but it's not going to matter because there is a lot of convective inhibition to deal with. So the overall idea is that if you can get surface-based storms, that would favor all severe hazards going into the evening, especially with any more discrete or intense supercells. I mean, this photograph says it all there, but that capping is going to be a bugaboo and likely will prevent a more widespread tornado event this time. So let's take a look at the NAM just for good measure here. So eastern Colorado, and we'll take one from southeast Colorado as well. And you see here, photographs, again, not quite as favorable given a weaker surface low. Southeast Colorado starts to look a little bit better, but again, that capping really starts to stick around there at 3Z. So this would be 9 p.m. capping, abundant capping here across the region. That's going to be the bugaboo in today's event, I think. So let's take a look at some convection allowing models, and then we will call it a video. So this is the 12Z HRRR. So not a super great depiction of ongoing convection. Doesn't really have a lot of convection there in northeast Colorado and then in the panhandles as well. So we'll take this with a grain of salt. But you see, throughout the day, not much happens. Not much happens. This is at 5 p.m. We still see a quiet target area here because of that delay in initiation due to that low stratus hanging around. Storms eventually do fire near the Denver metro, start to work their way southeast. They tend to struggle for a little bit, and then eventually you see more robust development there near and east of the Denver metro. But this is at 3Z on the HER, so that would be 9 p.m. I like to subtract an hour or two out across from these models for initiation, so maybe 7 to 8 p.m. That's awfully late. So I think by the time that storms may be able to get good as they move into eastern Colorado, it might be after dark there. So from a chasing perspective, doesn't look all that appealing to me today. That's why I decided to forego today's event. You see on the HER, they do stay discrete for a little while and then try to cluster a little bit as they move into eastern Colorado. We will take a sounding out ahead of these storms to see what the HER is showing, and you see abundant capping in place despite a very nice looking photograph there. So the models are all on board with quite a bit of capping, so storms may struggle to become surface-based here as they move into eastern Colorado. So I think, again, that's going to prevent a more widespread tornado event with today's setup. Then an MCS rolls through Kansas into Oklahoma going into the morning hours tomorrow. Let's take a look at the ARW model. So we'll take a look here. You can see through much of the day, storms struggle, and then finally about 0 to 1Z, so 6 to 7 p.m., storm initiation there in eastern Colorado. Discrete supercells move into eastern Colorado, western Kansas. They remain discrete for a little bit longer than the HRRR, but again, struggling to become surface-based, I would imagine, given surface temperatures remain cool and that capping sticks around. NSSL WRF, much of the same, struggles for much of the day, then eventually storms fire. This is at 4Z. Storms start to get a little bit more robust in eastern Colorado. So that is very, very late. That is 10 p.m. And then moves into southwest Kansas. And then finally, the FV3, just to show you one last convective allowing model. See storms start to percolate. FV3 does have a little bit more robust updraft signal there around Denver into the late afternoon, 4 to 5 p.m., but they struggle for a little bit, and then the main show starts to fire up 2 to 3Z, so 8 to 9 p.m. becomes an MCS rolling through Kansas. So models are pretty much on the same page for today's event. Again, we have an enhanced risk level 3 out of 5 for much of eastern Colorado into southwest Kansas, including the Denver Metro down the I-25 corridor toward Pueblo, areas to the east, Garden City, Dodge City, Liberal, and places in between. All hazards on the table for today. Tornado threat, again, is at a 10% unhatched, so 10% area there for southeast Colorado with a large 5% surrounding that. Again, I'm very skeptical of the overall tornado threat given such strong capping that is expected to hang around. Again, the main thing we'll have to watch today is how quickly does this stratus burn off and how warm do those surface temperatures get. If we can get into the mid-80s, even the low to mid-80s, I think we will have a chance to get surface-based convection and more of a robust tornado threat. But most of the models are on board with temperatures remaining in the low to mid-70s, and therefore lots of capping will stick around across this region, preventing surface-based storms for the most part. But nonetheless, SPC does have a 10% area for tornadoes. Damaging wind and large hail going to be the main threats. I think especially large hail in the early portion of the convective life cycle, especially across eastern Colorado where that 30% hatched area is. And then damaging winds once storms congeal into a line going into eastern Colorado, southwest Kansas. So with that, thanks for watching, and we'll see you in the next video.